which consists of some of the best minds of our industry. It publishes technical books, newsletters, and a prestigious journal, distributing the wealth of knowledge to all its members. Working with government departments, ISHRAE helps formalize industry codes and standards. Through its technical committee, ISHRAE promotes research by offering financial support to student members to carry out groundbreaking work in technology, systems, and processes. Our educational wing, ISHRAE Institute of Excellence, organizes training programs and workshops to help our specially designed certification programs under ICP, that is, ISHRAE Certified Professional, empower professionals to always be in step with the prevailing technology. Specially designed courses for technicians are offered to meet the ever-increasing demand for a skilled workforce. ISHRAE organizes exhibitions, conferences, panel discussions, and product presentations throughout the country. We organize the industry's largest international exposition in South Asia, ACREX India, to showcase the cutting-edge technology, innovation, and provide a platform for closer interactions amongst the decision makers in the industry. The ACREX exhibition is now growing from HVAC and R show into BFA, Build Fair Alliance. This brings together several allied shows connected with the building services industry, all at one location. Our chapters organize several other popular events like ACREConf in Delhi, Raycon in Kolkata, Symposia in Mumbai, TechFest in Goa, and many more. We are committed to provide training and career guidance to our student members through seminars, lectures, quiz contests, and site visits. A-Quest, a prestigious quiz competition organized by ISHRAE to catalyze the transformation of the budding engineering professionals. ISHRAE provides a platform to potential employers to select student members for careers in HVAC and R industry at the ISHRAE Job Junction. Young minds are made aware of the need for saving power, clean air, and sustainability. The K-12 initiative of ISHRAE focuses attention on school students' development to inculcate a scientific fervor and help develop them into responsible citizens. Speedy information is imperative to keep moving forward in this hyper-connected digital age. Searcher, a specifically designed search engine, is now available, which allows access to a well-catalogued database on HVACR and building services industry with just a few clicks. ISHRAE cooperates with various national and international bodies, industry, governments, academia, think tanks to promote the concept of sustainability, environmental protection, and energy efficiency and conservation, to enter and explore the universe of the Indian HVACR industry. Log on to ISHRAE.in that unfolds a panorama of information. Let us engineer a sustainable future together through ISHRAE.
Welcome to Mayank.
Yes, sir. Am I audible?
Yes, audible.
Shall we start? Sir, shall we start?
Yes, sir.
So, good morning and a warm welcome to everyone present here on the occasion of GMIT Student Chapter 3rd Revival ceremony organized by ISHRAE Ahmedabad and Gyan Manjari Institute of Technology, Bhavnagar. Myself, Mayank Pariyar, and I will be the host of this event today. Thus, once again, I welcome all the participants and delegates present over their screen today. We all know about the current situation hunting the human life all over the world and the problems that are faced by us in the day-to-day lives. That's COVID-19. Even though this through the times we found every possible way to engage ourselves into our professional and academic lives, thereby maintaining the momentum or say the pace of learning and development. Even though everybody isn't physically present and looking through their screens, we tend to make this event a great success and keep the pace moving forward. Before beginning the event, I would like to ask all the viewers to stand at their places and pay respect to the national anthem. And I request to all the keep their respective audio and video feeds off for the meantime.
जनगण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड़ उत्कल बंग विंध्य हिमाचल यमुना गंगा उज्ज्वल जलधि तरंग तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जनगण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे
Thank you all the participants. Now, we are going to attend expert talk on HVAC system in pharmaceutical industry by Mr. Sanjay Adhvaryu. We are heartily welcome to behalf of GMIT. Sanjay Adhvaryu sir is a past president ISHRAE Ahmedabad chapter, and in nowadays he is a senior vice president at Scenario Suvidha Engineers India Private Limited Ahmedabad, and he is a BE Mechanical from LD College of Engineering and MBA from BK School of Management with professional experience of more than 30 years in HVAC field. Since last 20 years, he is working at Scenario Suvidha Engineers India Private Limited at their Ahmedabad branch. Presently, he is heading Ahmedabad office and looking after business in Gujarat and part of MP and Rajasthan. And he started his career with L&T. He worked for a Petrolifer and Corporation for around 9 years. He is an ISHRAE member since 1999. Behalf of GMIT, I am like to request to Sanjay sir give session to our participant. Sanjay sir.
Thank you, ma'am. Give me a moment to start my presentation, please.
Perfect, sir.
So now you can see the presentation slides.
Yes, sir.
Okay.
Yes, sir. Yes, sir.
Good morning to everybody. I am pleased to give you this presentation on the platform of ISHRAE Ahmedabad chapter. As you all know, ISHRAE does lots of things for air conditioning professionals. Along with services to air conditioning professionals, we do provide some knowledge sharing platform to students also. And on that platform, I am giving you this presentation on recent trends in HVAC for pharmaceutical industry. This is a presentation on application of air conditioning in industrial environment. So when I am talking about HVAC, you should know what is HVAC. So HVAC is a term which says heating, ventilation, and air conditioning. Now, when we are saying heating, most of you considering air conditioning only as a lowering the environmental temperature of the application area. But in some applications, you need to heat also. In some environment, you need to heat your environment to reach the thermal comfort of
existence into the business.
Please, others, please keep your microphone on a mute mode, please.
राजेंद्र भाई તમે જ અનમ્યુટ कर दो ना બધાને, so it would be better.
Sanjay sir, you are also mute.
Sorry, this initial glitches. So what is the difference of HVAC in pharmaceutical application? When we are talking about pharmaceutical deals with human health, and the product which is made by pharmaceutical industry is administered to the person whose health is not good, he is sick. So when you are dealing with a human life, your product should be contamination free. Now what is contamination? Contamination is any impurity which is undesirable in the product. Now you may say that why I am talking all about pharmaceutical when I am talking in a mechanical engineering platform. Friends, please understand that when you want to serve your client, when you want to design your systems for any of your projects or any of your requirements, you have to understand user's requirement, the person or the process what type of conditions they require. So it is very important for us to understand the application thoroughly while designing our aspect of mechanical engineering. So that is why I am talking about pharmaceutical industry first. So when we are talking about contamination can be of three types. One is contamination to the product. So what is that? Whatever you are manufacturing drugs, the contamination which is happening to that product is to product. Then contamination from product. So what is contamination from product? See, you people, I do not know, you people may not be that mature, but those who are aware about the contraceptive drugs which are used for the birth control. Now, manufacturing of that product, when it is being manufactured, it can affect the person who comes into the contact of that product. Suppose some male is working in a contraceptive plants manufacturing female contraceptives drugs which are taken orally. That powder can active female hormones in that person if it has been inhaled by that person. So that is the contamination from product. And when we are talking across the product is you are making so many drugs inside your facility. So there will be contamination from one product to other product. So that is across the product. So all pharmaceutical industry products must be produced in air conditioned and clean space. In earlier days, we have seen people making tablets in garages, in their bungalow garages. But now WHO, FDA and GMP are very strict and they take stringent actions against you if you are not taking care of your environment while producing the products. You must have read in lots of communications on pharmaceutical application wherein people have been or companies have been banned in US or Australia to export their drugs because of this violations of rules of GMP. So what is HVAC for pharmaceutical application? In normal comfort air conditioning, we talk only about temperature. In some stringent manufacturing application like textile, like tire manufacturing, we talk about temperature as well as relative humidity. While in manufacturing in pharmaceutical, we talk the third aspect of cleanliness class also. What is cleanliness class? Cleanliness class is the amount of particles allowed inside a production facility. We will talk about cleanliness class and how it is defined in later slides. But I know you must be aware about temperature and relative humidity. So I am not explaining you right now what is temperature and what is relative humidity. So when we are talking about pharmaceutical, a drug can be taken in different form. Some people takes pills, that is oral solid dosages. Some people apply creams or ointments. Some people take liquid. Liquid you can take it from mouth, you can take intravenous. Then you take injections, that is injectable. Now in COVID situation, you must have been aware about the inhalers. Now these sprays and inhalers are a type of drug delivery system which you can take it from the nose. These transdermal patches are drug delivery system which are taken or applied to the person through his skin. If you people have seen in olden days, those who are suffering with rheumatoid, that is VA, they were applying a black patch on that place where they are feeling the pain. These are initial form of transdermal patches. Today there are very advanced transdermal patches available in the market which can deliver drugs in a very administered manner. Then there are some non-conventional type of drugs, that is suppositories. Suppositories are the drugs which you take it like enema. You just can Google what is enema and you will able to understand what I am trying to say. when we are talking about oral solid manufacturing process, why I'm talking about little bit about the process also, because that will give you idea that how these products are being made. So there are sampling and dispensing, there is blending, there is granulation, there is compression, there is coating, and there is packing. Now, when you have when you are taking some pills, you must be aware that people or your doctor will write to you saying that you have to take 300 milligram tablet. So what that 300 milligram is the real drug, and rest of the pill is of say starch or some product which you can easily take orally. So when you want to have those active ingredient in a small 300 milligram in a tablet, what you do is you first blend that active ingredient into the base material. That material is then granulated. So when granulation is a homogenizing that material, when you are making a product, say you are making thousands of tablets and your bin size is say 20 kg, so you have to your granulation or blending should be so that all the tablet is giving you 300 milligram of that active ingredient. What is compression? Compression, as the name suggested, is compressing the material into a tablet form. Coating. Coating is, see, when you take a tablet, it may be very bad in taste. So what you do is you do a sugar coating, which gives some good finish as well as good taste when you take that tablet orally. And packing of tablets is either it is in strip form, either it is in blister form. It can be in vial also. Sorry, vial. You can it in bottle also. So let us talk about what is air conditioning system. Now I have shown here an airflow diagram. This is a schematic diagram which is prepared for one of the compression room. Now if you see here in this, you can see this is the compression room 3. There is a temperature that is 23 plus or minus 2 degrees centigrade. Then RH is not more than 60%. Now class at rest, this is the cleanliness class, and here it is defined as ISO 8. So this is what you are supposed to take care when you are doing pharmaceutical air conditioning. Now let us talk about the air conditioning system itself. Now this portion is double skin air handling unit. This is the pre-filter, this is the cooling coil, this is heating coil, this is fan, this is fine filter, this is volume control damper. This volume control damper controls the flow. Then this is fire damper. Fire damper is normally required for isolating the system in case of fire. Then this is velocity sensor. This is supply air duct which is going to the room. This is the air terminal which is inside the room, and this is, in this case, this is filters and this is HEPA filters. We will talk about HEPA filters little later. Now this dotted line is return line, return duct system. Now here, if you see here, there is a filter, there is a damper, and there is a grate. this is a return air path which is going back. This is smoke sensor. Smoke sensor is if there is any smoke inside the area, it will be sensed here, and this will give the fire damper signal to close. Then this is temperature and RH sensor. How it is used, we will discuss little later. So components of air handling unit system, there is an air handling unit, supplier duct, supplier distribution. Supplier distribution, when we are talking about HEPA filters or grills. You must have seen a diffuser when you go to any multiplex on the ceiling. Those are comfort air conditioners. In pharmaceutical, you have filters at the outlet. Then you have return air collection. That is again return air risers, grill. You have return air damper, return air diffusers. Then you have return air duct. So what is air handling unit? Air handling unit is the equipment which treats the air. Nowadays, double skin type of air handling units are used. What is double skin? This AHUs have double skin construction. These panels are double skin which has insulated. So there is no heat transfer or heat losses from the air handling unit to the outside. Now, if I see the cross section of this air handling unit, you have return air damper, return air into the room, return air into the AHU. Then this is primary filter. These are normally G4 filters. Then this portion is housing chilled water and hot water coils. Then this is fans. This is fine filter, and this is supplier damper. So this is a supply connection. This is return connection. So G4, any primary air filtration is done through G4 filter. In cooling coil, it is cooled. In heating coil, it is heated. Fan gives you the pressure and required quantity of air inside the area. Fine filter filters the air to achieve ISO 8. In this case, you need some fine filters. We will talk about filter also little later in this program. So this is again a schematic view of air handling unit. This black enclosure is double skin panels. This is return air. This one is fresh air, because fresh air is very important. This is a bag filter. Bag filters are normally not washable, not cleanable. In foreign countries, people use this throwaway type filters extensively. But in India, people use washable type G4 filters. Then this is the chilled water coil. This is hot water coil. This is fan. This is fine filters. And this is supplier connection. So we talk about air handling unit in general. Now, what is fans? Now fans, there are normally three types of fans which are used in HVAC, in pharmaceutical air conditioning. One is DLDW forward curve fans. These are used for low pressure requirements when you do not have very fine filters in discharge. You use forward curve fan. DLDW backward curve fans are fans with a high efficiency, and these are used for normally higher pressure where you have HEPA filters in AHU or in terminals. Recently, plug fans are very popular in pharmaceutical air conditioning. This is something hybrid version of axial and centrifugal fan. If you see here the difference between this SISW or DIDW forward curve and backward curve fan, you will require pulley, you will require belts to drive this fan. While in plug fan, you can use direct driven. In this case, you can see motor and fan on the same assembly. What is advantage over here in pharmaceutical using plug fan? Since the fans are directly mounted, belts are not there in the system, because belts shred some particles in running, and that is, if gone into the area, can create a contamination. So avoiding belt application, the plug fan is now popular. Recently, these EC fan motors have come into existence, and this is normally works with a plug fan. These are very high efficiency motors in the range of E4, IE4 category. However, the limitation here is you cannot have a very large EC fan motors commercially. So if you have a large air volume, you have to use number of fans in particular AHU. However, the controlling of fan speed is very easy in this case, because this motor can take direct control, direct signal from your building management system. Now, let us talk about the filters. The way I was talking, these pre-filters are, these are the standards of G3, G4, F7, F8, H9, H13. We will talk about this standard also, but in G3, G4 is normally a pre-filter. F7 and F8 is normally a fine filter. H9 is semi-HEPA. Normally semi-HEPA are housed inside the AHU itself, and H13 is HEPA filters. When you have an injectable facility, you may go for plenum HEPA also inside the AHU, and that time you use either H9 or H13 filters. So what is G, F, H and U stands for? It is international classification as per EN 779. Now this G1, G2, G3, G4, F5, F6, F7, F8 are all based on the weight arrestance of the dust, testing dust particles. I am not going into the detail of how these filters are tested. I am just giving you some idea about what is G4 or F7 filters. So G and F are normally tested by weight arrestance. What is weight arrestance? You pass a test duct with particles, measured particles from the filter, and you weigh that dust particles after the filter. Now, if it can arrest 60% of the dust particle, then it is classified as G1. If it can arrest 90% of the test duct, then it is classified as G4. Same way, when you are talking about the HEPA filters are H9, H10, H11, H12, H13 and H14. H9 is normally used in plenum, as I told you again earlier. H13 and H14 are normally used in the terminal. Terminal is at the room ceiling itself. Then there are some nuclear facilities which require very high grade of filtration, where ULPA filters, ultra high efficiency filters, are also used, and those are U15, U16 and U17. Along with that, inside, if you see, there is EU1, EU2, EU3, EU4. These are Eurovent standards or DIN standards of classification of filters. Now, area classification, when I said ISO 8, or when I am saying class 1 lakh, so what is that 1 lakh? So when your area, the dust particles of more than 0.5 microns are 35 lakhs 30,000 in a sample of 1 cubic meter, your area classification can be classified as ISO 8 or class 1 lakh. Normally, when HVAC industry, we provide class 1 lakh, class 10,000 and class 100. So that is class D, class C and class B. Even class A also you can achieve through putting HEPA filter sealing inside the manufacturing area. So this is the area classification. Now every area classification have some data about 0.5 micron, 0.1 micron, 0.3 micron, and every micron size will have a specific numbers for per cubic meter sample. Now let us talk again about ducts. Ducts are the items which are used to carry air from air handling unit to the room. It can be GI rectangular ducting, it can be round spiral ducting, it can be flexible ducting. In modern times, now pre-insulated ducts are also used. These are made from puff panels or PIR panels or fiberglass board. These are normally used in comfort air conditioning. In pharmaceutical, you have to have duct leak testing, because when you are dealing with pharmaceutical application, you have to prove, or you have to installation qualification. During the installation qualification document, you have to prove that whatever equipments you have installed are working to the required standards. So duct leak testing is a machine which tests the leakage of ducts from the air handling unit. There are SMECNA standards available. There are machines which have orifice calibrated to measure the differential pressure. Earlier, when these machines were not available, we were using smoke or soap bubble test to carry out the duct leak testing. This is a photograph of duct leak testing machine. This is the controller part of it. You have a printer also there, which can print the amount of leakage from that duct. You have to feed certain parameters while ducting testing. Why duct leakage is important, or measuring the duct leakage is important? any energy which you consume should be used in proper way. If the air is leaked from the duct, you will lose that energy. In duct leak testing, in duct leakage, you normally lose around 10 to 30% of your air. I talked about fire dampers. Normally, there are two types of fire dampers. One is the fusible link type of fire damper. This is the fusible link, which is a bimetallic link which has a link which can melt at say 60 degree, 70 degree, 80 degree, 90 degree as per the material composition. It is a spring loaded. So once this link gets melted, the damper gets closed and airflow to the area is closed. This is actuator type of dampers. Actuator is a electromechanical system which gives damper an additional force to close in case of external sensor, external control sensing, like smoke detector. This is a smoke detector which sense the smoke and gives signal to this actuator to close, and the airflow to the area is closed. Then in pharmaceutical, this airflow monitoring station is installed. What is airflow monitoring station? In pharmaceutical, it is very important to have an air change or constant air supply to the area, irrespective of filter loading. So in case of if you have a filter which is clogged, you need to increase the fan speed by variable frequency drive, which increase the fan speed. This airflow monitoring station works on a pitot tube principle. This is a duct type airflow monitoring station. You can have a pitot tube in a single two tube configuration also. This is DPT. DPT is differential pressure transmitter, which is having a high and low pressure connections. So what this equipment totally does, this measures velocity pressure and tries to create a constant velocity of air into the duct. Then supplier distribution. You have grills. You must have seen these grills in your auditoriums, multiplexes. These are fixed bar grills. These are adjustable grills which have a double deflection, so you can deflect the airflow as per your requirement. These are jet nozzles. If you are going into any big airports or in atrium area of the malls, these nozzles are seen. This is a high velocity air throwing devices which gives a better coverage in long distance. Then you have diffusers. You have perforated sheet or swirl diffusers. This swirl diffusers gives you a turbulent flow inside the area, and it goes in such a way that the almost 90 to 95% of your area gets covered. Perforated sheet is normally used below the terminal HEPA filters. Then terminal HEPA filters, when we are talking, these are the housing for terminal HEPA filters. These are the HEPA filters. These are normal standard HEPA filters. This is HEPA filter. This is hooded HEPA filters where you do not require box like this, you can directly place it into the ceiling. These are fixed with a pressure plate and with bolts, tightening bolts shown over here. So this is normal HEPA filters with a pressure plate. These are the bolts which are giving pressure. This is the ceiling opening. This is the box. This is the flexible ducting. This is volume control damper, and this is supplier duct. This is hooded HEPA filters where you don't require any boxes. It comes along with the box and a pivot like this. So you can put directly this into the ceiling opening, seal the annular area with any RTV sealant, and you connect this spigot with this flexible ducting to the supplier duct. So this is hooded HEPA filters. Now today this HEPA filters are in gel seal HEPA filter. There is a gel over here. Gel is a material which takes shape. So this diagram is little, you will not be able to see, but if you go onto any Google site, you will be able to understand how the gel seal HEPA filters work. This avoid all pressure plates and tightening of filters. It is very easy to handle, and this filters are now very in thing in pharmaceutical application. Then in pharmaceutical application, dust collection is an important part. So where it is required in drying, mixing, blending, coating, milling. I will not talk more about this here, but dust collection, how dust collection is done. See, this in airflow diagram, this is the dust collection. In granulation or in blending, you have a dust collection system which extract drug powder which are in coating or compression. When it comes into the atmosphere of the area, the person who is working on the compression will feel bad because he will inhale those powder. So to reduce that effect, dust collection systems are used. This is the dust collection equipment. These are the cartridge filters. So when air is taken from this is the fan. There is a compressed air which is used for cleaning this cartridge filters. So how this works, I will explain you. This is the inlet and this is the outlet. So air is taken in, it is pre-filtered, then there is a cartridge filter over here, and this cartridge filters all the dust of powder of that air, and clean air comes out from this outlet section. Whatever powder is being collected is taken out from the bin below. There are bag in, bag out HEPA assembly also. See, in some, when you are dealing with viruses, when you are dealing with bacteria, you have to, or when you are dealing with vaccines, you have to be very cautious about coming of or escaping of virus or vaccine or bacteria from area to the air handling unit. So you provide high efficiency HEPA filters in the return air also. You must have heard about the vaccine rabies, જે હડકવાની રસી કહેવાય છે. When you make this vaccine rabies, you have to control the vaccine particles, viruses going into the air handling unit, because air handling unit will be serviced by any person who will, if they are exposed to this rabies vaccine, they may get vaccine, they may get rabies. So bag in bag out HEPA assembly is normally used for such type of application. This is the photograph of bag in bag out HEPA filters. The upper section is a pre-filter and lower section is a HEPA filter. If you see in this cross section, the first filter is pre-filter and the second filter is fine filter. These filters are removed in such a way that it does not come in direct contact to the person who are handling these filters. Then another major process in pharmaceutical application is dehumidification. Some products requires very low RH. When you are compressing tablets, any moisture particles will create problem or lumps inside the bins of compression machine. So you have to have a very low RH area. So dehumidification is normally done in compression, in granulation, in oral solid dosages. These dehumidifiers are used extensively. However, in some sterile products also you require low humidity. Now, what is dehumidifier system? In this case, I am showing you a schematic diagram for dehumidifier, air handling unit with dehumidifier, and this is the chemical type, desiccant type dehumidifier. So this G4 filters remain common. You have one additional fan here to take care of the pressure drop across this dehumidifier wheel, which is a silica gel impregnated wheel. Then you have chill water coil, you have fan, supplier fan, fine filter. So everything remains same except this particular area. This is dehumidifier section. Now this is having a wheel which is impregnated by silica, and as you know, silica is very useful in absorbing the moisture. So this is the process system, and see, you want to use this silica again and again, so there is a reactivation circuit also, and this is the reactivation. So what you do is you heat outside air, take it from the heated air, passes over from the portion of the silica gel wheel and exhaust it out. So this way you can use this silica gel wheel again and again and again. So this is how it is shown over here. So if you see this 360° of this wheel, out of that 90° is used for reactivation and balance 270° is used for process. So any return air from the room is taken from this blower, passes through this silica gel impregnated wheel, low RH air comes out and passes through this cooling coil and goes to the area. Now in doing so, this wheel is loaded with the moisture, and we want to use this moisture, this wheel again. So what you do is, this portion you take out moisture from the wheel. So what you do is, you heat this reactivation air which is taken from the outside with either steam heaters or electric heaters, passes through this reactivated wheel and taking it, exhausting it out in the air. So along with this hot air, moisture is taken care and it is exhausted out in the atmosphere. So this portion again, from here again the wheel is charged. So this is the charging of the wheel and this is discharge of the wheel. So this is the chemical type of dehumidifier. You can use the DX type of dehumidifier, which is working on a vapor compression cycle. Here the moist air passes through the evaporator and it is taking care. But the moisture is condensed because of the evaporator. Normally in pharmaceutical, chemical dehumidifiers are extensively used. Then these are pressure independent control valves. These are used to control the water flow for the chilled water and hot water flow in the air handling units. This works on temperature and RH feedback. On temperature and RH feedback, this gives signal to this actuator to either close or open the system, water flow to the system. Now this is the pressure independent control valve. What is the advantage of pressure independent? Normally people use two-way, three-way valves, but today the recent trend is to use pressure independent control valve because it gives the dynamic control of flow also inside the system along with the flow of delta T or control of the delta T. Then these are air-cooled chillers. Now today people are using evaporative, these air-cooled chillers to reduce the outside temperature. What they do use is evaporative cooling before the air enters into the system, so that you get a little better temperature at condenser coil. Suppose outside is 45, so you may get say 35 or 38 degree centigrade air entering into the condenser coil, which gives a better efficiency. Then thermal comfort, physical phenomena. See, when people are giving heat, human body always gives heat through 4 modes of heat transfer. One is radiation, second is convection, third is evaporation, and fourth is conduction. Now, if you see, the radiation and convection are major part of the heat which is emitted from the body. So for controlling radiation and giving better comfort to the and convection heat, nowadays people are using radiant cooling. This is not normally used in pharmaceutical. I am just giving you this idea as we are talking about the recent trends in air conditioning as well as air conditioning as well as including pharmaceutical. This radiant cooling is normally used for comfort cooling. Here you cool the floor, or you cool the walls, or you cool the ceiling of the area to be air conditioned. Because when you have cooled surroundings, your heat, as we talked in the previous, radiation and convection heat transfer increases because of this cool environment around you, and this gives a very good feeling to the person who is inside the area. The other benefit of radiant cooling is this chilled water. Normally we use a 7 degree outlet in chiller. Here you can use 15 degree C as an outside outlet of the chiller. as you increase the outlet temperature of the chiller, your chiller efficiency increases. So radiant cooling gives you a better efficiency in chiller also. Now you must have known about the inverter technology. You must have known about the VRF technology. What is VRF? VRF is inverter based air conditioning, but a normal air conditioner where you have one-to-one condenser unit to one evaporator unit. In VRF, you have multi indoor units against one condensing unit. So what is inverter technology? Inverter technology, you run compressor on an inverter. Based on the return air temperature, you can control the speed of compressor. So energy can be saved. Normally with start-stop type of control, your starting current of compressor is very high, which gives you a very high inrush of current and gives you a more power consumption, while in inverter you run it at a very low speed or as per the desirable speed, and you don't have on off, so inrush current will be minimized. So this is all what I have to say. If you have any questions, you can write to us on our ISHRAE mail ID and I will be happy to answer you. Thank you.
Thank you, sir.
Now I am handing over mics to you, sir.
Mayank,
Man,
Thank you, sir. Ruchit sir and Hardik sir is here, so we are heartily welcoming you to this ceremony on behalf of GMIT. Now I would like to share video which is the journey of ISHRAE GMIT student chapter. So video is there. GMIT became a part of ISHRAE under Ahmedabad local chapter in 2018. And for know this journey, we need to go in past. So let's go. So GMIT became a part of ISHRAE under Ahmedabad local chapter, and the installation ceremony was held on 5th August 2018 at JB Auditorium, AMA Ahmedabad, and in which President, Secretary and CWC member take oath in presence of Kamlesh Mehta, who is the installation officer in ISHRAE, and explain role and responsibility of each post. And CWC team of Society at 2018 was Kogabori Muhammad Akhtar Abdul Rauf was the president, Neil Joshi was secretary, Dhruv Trivedi was the treasurer, Rajan Trivedi, Anantu Nair, Dave Devarshi were CWC members. We also organized monthly meetings and we organized webinar too, like green conditioning on 27 July 2018 by Mr. Nishant Gupta, and second one was the importance of ventilation on 28th December 2018 by Mr. Gaurav Vasudev. We also attend Cool Fest 2018 on 5th August 2018 in JB Auditorium AMA campus. There was a ISHRAE Job Junction online test on 27th October 2018, in which from our institute total 2 number of final year students was eligible, by which they cleared this exam and shortlisted Mumbai interview. Let's talk about Society Year 2019-20. On 28 February to 2nd March 2019 in Mumbai, 2 students of our institute were visited HVAC India 2019, in which TO and FRO railway tickets and accommodation were sponsored by ISHRAE Ahmedabad chapter. Then we organized one-day workshop on 6th February 2019 at GMIT. And our chapter revival for Society Year 2019-20 was held on 12th April 2019 at Bhaskarai Pandya Community Hall, AMC, Ahmedabad. Our students also attend technical talk on solar thermal year-round air conditioning by Mr. Gaurav Patel on 8 June 2019 at AMA Ahmedabad, and 24 students and 1 faculty member participated in industrial visit on 29 June 2019 at Hitachi World and Synergy Agro Technical Private Limited, Ahmedabad. We also had an expert talk on solar refrigeration system by Dr. Virang Oza on 2nd August 2019 at GMIT campus. We also run 1 degree campaign in GMIT. And we also organize internship program in which Dhruv Trivedi and Pranav Dhola from 7th semester student has completed 1 month internship at Dhandok, Ahmedabad. And in Aquist Quiz 2019 at chapter level total 25 students were participated. Let's talk about Society Year 2020-21. 5th February 2020 we organized one-day workshop at GMIT campus, in which our 3 sessions were taken by Mr. Prashant Pathak, Dr. Deepak Pandya and Mr. Hardik Shukla. Now let's talk about HVAC India 2020, which was held at Delhi on 27 February to 29 February, and in this event total 2 students were visited from our institute, and TO and FRO railway tickets and accommodation were sponsored by ISHRAE Ahmedabad chapter. This comes with lots of difficulty cause of pandemic, but this can't stop us. We also organized webinar on energy conservation opportunities in cooling tower on 6th May 2020, which was held by Professor Kunal Khereya, who is head of the Department of Mechanical Engineering of our institute. We didn't end it here. We also have lots of webinar on during lockdown and unlock. There was a virtual factory visit too, virtual tour of the art manufacturing unit of HVAC on 29 July 2020, and in Johnson Control and Hitachi's virtual visit our student participated on 29th August 2020. On 5th September there was an online Cool Fest 2020 and our 15 number of students were participated. We also organized chapter level weekly meeting. Every month ISHRAE send us journals and as well as students login. There is not a single week goes by without us being in the newspaper. Wait, that's not end. In future, we also have ISHRAE Job Junction and Global Student Poster Design Competition 2020. And that's the all about journey of GMIT ISHRAE chapter. Thank you.
Superb. Congratulations.
Thank you, sir. So now I would like to request Sanjay sir for continue the session to chapter installation ceremony. Sanjay sir.
Thank you, ma'am. Now, I think you should share the screen of Devarshi Dave, who is be taking oath for president. So,
Yes, sir.
Devarshi, are you ready?
Yes, sir. Yes, sir.
Thank you. The general leadership of the chapter is entrusted to you. You will act as chairman of the board of governors, act as chief executive officer, ex officio, and be a part of all the committee. As chief executive of the chapter, it will be your responsibility to see that the policy directive of the society and your CWC are carried out. You are the one to whom the member of the chapter can and will direct their criticism of the chapter policies and activities, and you must render specific satisfaction to them all. Service as a chapter president of this society carries with it a great honor, a responsibility, and a lot of hard work. Do you, Mr. Dave Devarshi Ravichandra, promise to fulfill the duties and responsibility of your office as specified in the chapter operation manual?
Yes, sir. I do, sir.
Thank you. Your response being affirmative indicates your willingness to accept the responsibility being placed upon you by your chapter, your region, and your society. I therefore install you as the duly elected and sworn president of the Gyan Manjari Institute of Technology, GMIT student chapter of ISHRAE Ahmedabad chapter. Thank you.
Thank you, sir. Thank you, ISHRAE Ahmedabad chapter as well as GMIT Institute.
In closing,
Yes, sir.
may I remind you that you have capable, willing chapter members to assist you, but the success of the chapter is in your hands. We will now present your other officials and members of your CWC. Okay?
Thank you, sir.
Okay. Now,
Okay, sir. Okay.
is Deepika ready?
Yes, sir.
Thank you. Ms. Deepika Vishnu by Rajai, it will be your responsibility to keep due records of meetings, attend to correspondences, and be an aid to the senior officers. Do you, Ms. Deepika Vishnubai Rajai, promise to fulfill the duties of the office as specified in the chapter operation manual?
Yes, sir. I do, sir.
I am pleased to install you in the office as chapter secretary. Thank you, Deepika.
Thank you, sir.
Now, I will request Mr. Yash. Mr. Yash Jayesh Bhai Shah. Are you ready? Yash, are you ready? Please unmute your. Yes. Mr.
Yes,
Yash,
sir,
are you ready?
Ready, sir.
Okay. Mr. Yash Jayesh Bhai Shah, it will be your duty to receive all monies, pay authorized accounts, and to give due accounting financially whenever you are called upon. Do you, Mr. Yash Jayesh Bhai Shah, promise to fulfill the duties of the office as specified in the chapter operation manual?
Yes, sir, I do, sir.
Thank you. I am pleased to install you in the office as chapter treasurer.
Thank you, sir. Thank you, sir.
Now I invite all member of the CWC, Mr. Mayank Jaisukbhai Varia, Mr. Anantu Nair, and Pritesh Kumar Pandya. All three are present.
Yes, sir.
I can see Jayesh. I can see Anantu. I can see Mayank. And where is the Pritesh? Pritish Kumar Pandya.
Yes, sir. I hear. Here, sir.
His screen I am not able to see. His face.
Sir is present, sir.
Okay. Pritish, are you there?
Yes, sir. I am here, sir.
Okay. I can hear you, but I cannot see you. Now I can see you. Good. So all three of you, because of your demonstrated interest and activity in society affairs, your fellow members have elected you to represent them on the CWC of the chapter. It will be your responsibilities to meet as a committee to deliberate and take action on all matters that come before it. Since the CWC is the governing body of this chapter, it is an honor and a privilege to serve on it. And it is my pleasure to welcome you to this activity of society and to install you as the officers and members of the CWC of the Gyan Manjari Institute of Technology GMIT student chapter of ISHRAE Ahmedabad chapter. These are all your chapter officers and they need deserves to your support. Thank you, friends, for your support. Now I hand over this session to Hardik Bhai. Hardik Bhai.
Yes, sir. Thank you, sir. It's really good to learn from you and as well as to install the chapter. So I'm very much thankful to you and team GMIT for reviving this chapter in even in difficult time. They are well connected in all the programs. Sanjay, till date from ISC only we have conducted more than. So we tried our best for the students to connect with this HVAC and our industry platform. Thank you, sir. So now I
want to say a few words before closing from my side. See, friends, whoever are there on the webinar, please take maximum out of all these opportunities which you people are getting for industry coordination, like this efforts of ISHRAE Ahmedabad. Please note that this will help you in your professional career. Wherever you go, you will be judged from how ready you are for industry, not only by your marks. See, you may be a very good at studies, but if you cannot express your views or exhibit your knowledge, it will be not useful in your professional career. So try to take part of all such activities and take maximum out of this offer that ISHRAE Ahmedabad chapter is putting forward in terms of installing this student chapter to you. Please note that we have seen lots of rankers who does not perform well in their professional career, and we have seen lots of backbenchers who are successful as an entrepreneur or businessman. So please take full advantage of this opportunity. Thank you very much for listening to me for 45 or 1 hour. Thank you very much.
Okay, sir. Thank you very much, Sir Sanjay sir, and thank you ISHRAE Ahmedabad chapter for continuous support us. Thank you, Sanjay sir. Mayank.
Sir.
Kunal,
So
sir.
now I would like to invite Professor Kunal Khireya, who is the head of the Department of Mechanical Engineering, to give speech of honor. Kunal, sir.
Good afternoon to all of present over here, all the dignitaries as well as all the attendee students. First of all, I want to share some memories. In GTU, we have one faculty development programs on HVAC and R in association with the ISHRAE in the year of 2016. And if I'm not forget, at that time, Sanjay sir is also a president of the chapter, and we start to communicate for the establishment of the local chapter in our institute. And finally in the year of 2018, our efforts will comes, and we establish the chapter in 2018. And I congratulate all the past president of GMIT ISHRAE chapter for in past 2.5 years. Also, I want to congratulate all the students who have elected I want to congratulate Professor Wala sir for taking initiatives to run this wonderful different activities in our chapter. Also, in these occasions of third revival student chapters, I want to thanks to the ISHRAE Ahmedabad chapters, and especially Prasant Bhai, Hardik Shukla sir, and Rajendra Bhai for the continuous supports and taking very much good activities for our students also. So this is very good occasions, and we revive our chapter third times in a consecutive years. So I thanks to all the office executives of ISHRAE Ahmedabad chapters, as well as Sanjay sir to deliver the very nice talk on the HVAC fields in pharmaceutical fields. So thank you all, and I again congratulate all the students. So this is
Sir, thank you very much. Just I wanted to tell you that why I choose subject of pharmaceutical, because what I understand is Gnam Manjari has a branch in pharmacy. So
sir,
what I wanted was by this lecture, if those students also wants to have some knowledge about the air conditioning done in pharmaceutical application, they can also join this webinar. That is what my objective was, to select this topic. Thank you, Sarya sir.
And sir, I want to share you that our students of the third semester pharmacy, as we established the pharmacy institute in last year, so we have students in a third semester, and I think most of the students have attended this session, and they are taking the benefits of the wonderful knowledge of you, sir. Thank you, sir. Thank you. Now over to Mayank.
Thank you, sir. We are very glad to be part of ISHRAE student chapter, and in part of ISHRAE, we also gained bunch of knowledgeable things, and we also learned from ISHRAE that the learning is not dependent what the situation is there. However, the pandemic was there, but ISHRAE never compromised with giving the knowledge to their students. In behalf of GMIT, I am very thankful to Sanjay sir, Rujit sir, Hardik sir, ISHRAE Ahmedabad chapter, and all the participants to be here. Once again, thank you very much to be here.
Kunal sir. Hello, Kunal sir.
हाँ सर बोले. यस सर संदीप.
So હવે conclude करें કે end the session.
Yes sir, end the session. Conclude.
Okay.
Thank you very much to thank you very much.
Thank you, sir.